Welcome to our session on managing emergencies when intelligent algorithms fail. In this part of our AI Audit exam prep series, we will explore how to upgrade traditional incident response strategies to handle the unique threats posed by modern automated systems. In the real world, mastering this framework allows you to assess whether your organization is genuinely prepared for a crisis. You can apply this knowledge immediately to ensure your corporate emergency playbooks include the right experts and procedures, preventing a simple software mistake from turning into a catastrophic legal or reputational disaster. Let us start by looking at how the technology industry historically manages crises. In conventional environments, disasters usually look like a network outage, a malicious hacker seizing control, or severe data corruption. While these events are highly destructive, they are completely understood by technical professionals. To handle them, the industry relies on a global standard known as the ISO 27035-1 framework, which lays out a reliable 5-phase pathway for managing security emergencies. The first phase is to prepare, which means building your policies, defining your processes, and assembling your emergency team before anything goes wrong. The second phase is identify and report, which involves detecting the problem and sounding the alarm. Phase 3 is assess, where investigators figure out the severity and impact of the damage. The fourth phase is respond, where the team works to contain the threat, eliminate it, and recover normal operations. Finally, phase 5 is the post-incident review, where the team analyzes the root cause of the problem to learn lessons and improve future defenses. You can think of this conventional 5-step process like managing a house fire. You install smoke alarms to prepare, the alarm rings to identify the fire, you check how big the fire is to assess it, you spray water to respond, and you figure out why the stove caught fire during the post-incident phase. While emergencies caused by intelligent algorithms are a relatively new global phenomenon, we do not need to throw away this rulebook. We can adapt these exact same 5 steps to handle algorithmic crises. The most critical step for an organization's survival and long-term resilience is the very first phase, which is preparation. Most corporations already have an incident response program, but the vast majority have failed to adapt their policies, procedures, and staff to handle issues specific to artificial intelligence. Let us look at the 3 major types of algorithmic incidents you must prepare for. The first is the abuse of the system's output to cause harm to society. Imagine someone using a text-generating algorithm to instantly mass-produce thousands of fake, threatening letters to manipulate a local election. The second incident type is the disclosure of confidential or personal data that the algorithm absorbed during its educational training phase. This is like a corporate receptionist accidentally broadcasting a client's private medical history over the public intercom. The third type involves the system generating predictions that are biased, entirely incorrect, or hallucinated. Hallucination in this context means the computer is confidently making things up. Think of a digital map that enthusiastically tells a driver to turn onto a bridge that simply does not exist. An updated, automated ready response program must explicitly address these unique risks and their potential impact on human welfare. To prepare properly, an organization must update its emergency policies to tackle these specific threats, outline precise detection techniques, and establish ethical guidelines. A crucial rule of crisis management is that debates over the ethics of using an algorithm must happen far away from active incident response efforts. You do not debate the philosophy of breaking a window when the building is actively burning. Those decisions must be made when heads are cool. A massive part of this preparation involves maintaining flawless model documentation. When an emergency happens, investigators need to interpret exactly how the system makes decisions, its internal architecture, and the raw information it studied. This is typically done using a model card. A model card is essentially a nutritional label for software. Instead of listing calories, it lists the exact data ingredients and logic the system uses. Furthermore, this documentation must include a clear communication plan and escalation protocols. You must know exactly who to call, whether that involves internal business leaders, external public relations firms, or law enforcement agencies. You cannot fight a new type of digital fire with the exact same fire department. You must upgrade your incident response team. Alongside your normal technology and security guards, your team must include specialized subject matter experts and risk management professionals. First, you need data stewards or owners. These are the experts who intimately understand the specific data sets used to teach the algorithm. They are like librarians who know every single book in the library. Next, you need data engineers and scientists. These are the mechanics who handled the pre-processing and training of the model. Because they built the engine, they are perfectly positioned to interpret bizarre, anomalous behavior. Third, you absolutely must have privacy experts at the table. Their job is to guide the cleanup efforts to ensure that investigating the incident does not accidentally violate global privacy laws, data sovereignty regulations, or individual human rights. Finally, you need a brand new type of stakeholder called an AI ethicist. This professional serves as the moral compass of the team, specifically trained to ensure all technical fixes remain safe and ethical for society. Once you have your team and your rules, the organization must train them using standard operating procedures. This is typically done through tabletop exercises. A tabletop exercise is simply a simulated role play. The team gathers around a table, pretends a massive disaster is happening right now, and tests their reflexes and tools. These practice runs must be uniquely tailored to intelligent systems. The forensic tools you use to evaluate a normal network breach are completely different from the tools you need to investigate data poisoning. Data poisoning is a covert attack where someone secretly sneaks malicious information into the system's educational materials, forcing it to learn the wrong lessons. Imagine someone sneaking into a bakery at night and swapping the labels on the sugar and the salt. The bakery doors were not broken, but every cake produced the next day will be ruined. To catch a poisoning attack, the response team cannot just look at network security logs. They require deep access to the data lake, which is the massive central storage pool where all raw organizational information lives. By collaborating with data scientists to explore these data sets and analyze what goes into the machine versus what comes out, the incident response team gains the crucial experience needed to act swiftly during a real crisis. Let's quickly recap what we've covered today. We learned that while advanced algorithms present entirely new risks like hallucinations, privacy leaks, and output abuse, we can confidently adapt the trusted 5-phase ISO framework to manage the chaos. The absolute key to survival is the preparation phase. You must update your emergency policies to settle ethical debates before a crisis hits, and maintain crystal clear model cards so investigators are never flying blind. Finally, a successful defense requires a modernized response team that includes data owners, scientists, privacy experts, and ethicists, all of whom routinely practice their skills through specialized simulation drills. All the important topics and conceptual frameworks we discussed in this session are covered extensively in the multiple choice questions on RooCloud.com. You should ideally solve the chapter-wise questions to test your knowledge and reinforce your learning before moving on to the next session. Keep up the great work, and I will see you in the next session.